Good afternoon to everyone joining us. We'll go ahead and get started in just a couple minutes. Let the attendees roll in. For those just joining us, we'll get started in just a moment. Okay, hello, and welcome to the next member hour in our producer series. This installment is entitled Producing Sugar in Louisiana. My name is Sarah Rodriguez, and I'm the host of the program today. ASABE member hours were started as an opportunity for our members to learn, connect, and grow. In a few minutes, we'll get things rolling, but first, just a few ground rules. Please do keep your audio on mute throughout the presentation to reduce background noise. If you have any questions, you can either type them into the chat throughout the presentation, or we can open up for verbal questions at the end of the session. This meeting will be recorded and will be available for view later on our YouTube channel. Today, we're hearing from Anurag Mandalika. Anurag is assistant professor with the Audubon Sugar Institute at the LSU AgCenter. His research interests include automation and real-time data analytics in sugarcane processing, biomass and bioenergy, waste valorization, and investigating workplace development strategies. Please join me in welcoming Anurag.
Thank you so much for the introduction, Sarah. Good afternoon, everyone. And I appreciate being able to speak with you a little bit regarding growing sugarcane in Louisiana. Let me try and get my slides up as gracefully as possible and share my screen. If you can see my slides, okay? Is that okay, Sarah? Okay, perfect. Thanks, everyone. So as Sarah mentioned, I'm Anurag. I'm an assistant professor at the LSU AgCenter. We're not LSU main campus. We're kind of our own thing. We work mainly on the agricultural side of things, but we're primarily research and extension institute, and we work closely with the sugarcane industry in the state. I've been here for just over a year, having been a former Badger and a Clemson Tiger before that. So the agenda for today, I'll do a little bit of introduction about sugarcane, the plant, a bit about its history, how it came to be in Louisiana, and what the industry currently looks like in the state. I'll cover the three main sectors of agriculture, which is the field aspect of things, processing, the factory side of things, and then finally refining. And I'll talk a little bit also about the future of this industry, particularly guided from a research perspective. That's what we do for a living as scientists and researchers. So I'll focus on that and end. You can kind of follow things where they are going by paying attention to the footer at the bottom of the screen. If I've written everything correctly, it should mostly keep you in place. Okay, so what is sugar? It's a common word. There's many different types of sugar. In this case, we're primarily referring to sucrose. As you can see to the right, there's a structure. It's a dimer of glucose and fructose. It's a pretty important commodity in our lives. I'm sure you've experienced it already once or a few times today, probably in your morning coffee, or probably on a croissant, drizzled on something. But basically, the average American consumption is about 77 pounds per year, which is the highest in the world. Some of the reasons why we use sugars in foods and beverages is mainly the sweetness. Obviously, it imparts sweetness to foods and beverages. It is also a texturizing agent. Provides the crispiness to cookies. It also imparts color and flavor, primarily due to two different types of reactions, the Maillard reactions and caramelization, the browning reactions, as you call them, and then you can remember the flavor and the aroma. Think about getting a fresh batch of cookies out of the oven or a warm apple pie. Some of the flavors that you're getting are from these decomposition or browning reactions of sugar. It's also used as a preservative, similar to salt. It reduces the water activity of the foods, thereby extending their shelf life. Just a quick note of clarification, the consumption number shown above includes both sugars and sweeteners. And it's not just sucrose, it includes other types of sweeteners as well. So looking back where majority of it comes from, over 70% of sugar is produced from the sugarcane plant. We also make sugar from sugar beets. That's mainly in the Midwest and other parts of the world. This deals with sugarcane in my talk today, and we are looking at a grass that is a perennial grass suited to tropical climates. The stalks of the plant, which you can see in this first image here in the middle, the leaves and everything, they're typically discarded during processing, but the stalk is where the majority of the sugar is concentrated. We're looking at about 12 to 14% by weight of sucrose in the stalk. And this cutaway here shows a closer look at the stalk. These two nodes at the bottom is where new growth comes through. It's a perennial grass, so you don't have to plant it annually. But when you cut it down, the new growth comes through these nodes. And then the internode, the space between those nodes, is where the majority of the sucrose is typically present. It follows the C4 pathway. If you remember biology, there's two other pathways that came in the C3. The C4 is a more efficient pathway. It is one of, if not the highest production-based plant. What I mean by that is it's an efficient converter of photosynthesis. It puts out the most biomass compared to other plants out there. How did sugarcane get all over the world? We know from research that it originated in New Guinea, which is this island northeast of Australia, and then it spread to both India and China around those times. And then it kind of made its way through Arabia and North Africa and Europe. At some point, it also made its way to Hawaii. It obviously did not intersect Africa and then go through Central America. It went around the way, but 2D maps. And eventually, at some point, it came into the New World, primarily due to Spanish colonization, also ended up in South America and the Caribbean and North America and into Louisiana, where we are today. A little bit about the New World. The second Columbian voyage from the Canary Islands brought it to the Caribbean. And then it really was an industry sugar went from being an exotic spice to being a commodity that was used very widely. And it could not have done that had it not been for the enslavement of millions of people. That's part of the history that we need to acknowledge moving forward and dealing with the current state of the industry and looking to make it a more equitable industry if possible. So that's our history, and that's something we need to grapple with. Coming to the United States, you can see where sugarcane is currently grown in the US. Down at the bottom of this map, Louisiana and Florida are the majority of the sugarcane production, 50% Florida and about 42% Louisiana. It used to be more of at least now it's more even than that. This is data from 2018. You can also see going down Texas by the Rio Grande Valley in the southeastern part of the state. Sugarcane is also grown there, but it's not a massive amount. We mentioned it used to be in Hawaii. That industry ended or closed in 2014. There's a really nice piece by NPR on the final days of Hawaiian sugar. I welcome you to read it. It's a pretty good read. But what I want you to take away from this map is that Louisiana is the northernmost region where sugarcane is grown. If you remember, sugarcane is a tropical crop, and we are in a subtropical climate. So that'll lead to some challenges, which we'll encounter in a little bit. Looking at some statistics, this is sugarcane in the entirety of the United States. The first chart talks about the area under planting. This is going back 60 years, 63 years. The area has constantly increased over time. Around 2000 is when we start to see a decline. I think that's when the Hawaiian industry was starting to grow out. And then the second chart talks the biomass yield in hectograms per hectare. Again, for the same time period, we see somewhat of a decline. I think this is attributed to sugarcane moving into new areas and then the breeding not necessarily catching up with being acclimated to some of these new regions. But then in the last 20 to 15 years, or 10 to 15 years, it's been on an upswing. And then finally, this is showing the production and tonnage of sugar from this crop. And it's been on a steady increase. This drop off probably can be attributed to the Hawaiian industry going out of business. And then we've again been on an upswing since. This data is courtesy of the Economic Research Service of the USDA. Any crop you're interested in is a really valuable tool. So coming to Louisiana, it's an extremely important and vital industry for the state. Both economically and culturally, it adds about $3 billion in value and supports close to 20,000 jobs in all different sectors of sugarcane. Culturally speaking, it's been here for over 200 years, and the people that work in the industry, if you talk to them, they hope that it stays for another 200. This image is showing a picture of a parade from the Louisiana Sugarcane Festival. It's a fun event. They anoint a sugar queen. They do the Fado Do, which is a Cajun dance. Lots of food. Sugar is an inescapable part of the landscape. Okay, so coming to the sectors of that sugarcane industry is comprised of. So I've broken this down to three main sectors: the agriculture sector, whose main output or the product is the sugarcane crop; the processing sector, whose output is the raw sugar that the sugarcane is converted into; and then the refining aspect of the industry, which turns the raw sugar into white sugar. So we'll take this one by one. I work in the processing industry, so I'll spend a little bit more time on that, but I do want to touch the other two sections as well. So looking at the agricultural sector or the field sector, we have around 450 total farms, about 460,000 acres that have been planted in the entirety of the state. This is from a few years ago, so that number is probably close to about 500,000 acres at this point. It spans along 24 different parishes. So in Louisiana, we don't have counties. We have what are called parishes, part of our heritage with French, Spanish history. Church parishes got incorporated as jurisdictions for municipal matters as well. So we have parishes, the only state in the country that does that. And if you can see from this map, thinking Louisiana as a boot, most of the planting areas are concentrated in the southern part of the state and in the foot of the boot. But there has been somewhat of a northward expansion over time, especially as farmers see that this is a profitable crop to grow and process. It's been encroaching up north. Again, remember, this is a tropical crop in a subtropical environment. and it does not like to move a lot further north because of the threat of the freeze. And the freeze is something that the industry contends with every year. So that's something you have to be careful about. But some of the cold tolerant varieties that the breeding programs have been focused on seem to help with that aspect of its acclimatation. So I've broken this down into a few sections. This is by no means an exhaustive list, but we'll start with planting. The first picture shows you how planting is typically and more commonly performed. There is also a mechanized aspect to it, but this is by far still the way it's typically done. Whole stalks of sugarcane from seed cane, which is when it's first planted, are put into rows. As you can see here, people walk behind these trucks and then plant them alongside. The industry has been shifting to billets, which are shown in the image on the right. They're about 9 inches long, and they're basically the stalk cut up into smaller pieces. Especially on the harvesting side, this has become more popular, so much that 95% of all the harvest is done in terms of billets. So now you have a situation where the majority of your crop is coming out as billets, but you still want to do whole stalk for planting. So there's a little bit of transition there, but the majority of the planting is still done as whole stalks. It's thought to be a little better from a disease prevention perspective and whatnot. But that's typically how planting is done. We have a 9-month period of growth for sugarcane. It's not a whole year, just because, again, we're talking about preventing a freeze from attacking the crop. So harvest typically starts in September. And then it's mainly mechanized, right? And then the goal is to finish harvesting by the end of December or early January, avoid that threat of a freeze happening, which can ruin the crop. So this is what a combine harvester looks like in action. It goes through and it goes above the crop. The appendages you see here try to funnel the crop in, and then the leaves and everything get cut up and get blown behind the harvester, and then the billets are put through the chute into the tractor going next to it. And then there's a bunch of blades that cut the stalk into billets, and then they get funneled out. And if you're wondering what this looks like from inside a harvester, I actually got the chance to ride in one of them on a research farm, and it was a pretty incredible experience. So this is what it looks like. You're going over 12 feet high and above the crop, and then pulling it through and cutting it up into billets. So that's what the harvest looks like. It used to be harvested by machetes back in the day, but it doesn't really happen in Louisiana anymore. And then now that you have this cane harvested as billets, you want to transport it for processing. And there are some considerations here. It's during the fall, it's an inescapable sight of the Louisiana landscape. You have these 18-wheelers just going down narrow 2-lane highways, carrying about 100,000 pounds of sugarcane in the back of their beds and transporting them to factories. The transit time between field and factory can be anywhere between 2 to 3 hours. The longer the wait, the worse it is for the crop, because the sugarcane starts degrading the moment you cut it. It's exposed to microbial activity. If you think about these billets, they have 2 open ends, and that exposes the sucrose in the juice, and then it's great for microbes, especially as we have warm weather during that time of the year. As it gets cooler, that becomes less of an issue, but it's still something to contend with. So this is what transportation typically looks like, and the shorter the time to transport, the better. And something we have to talk about, in the previous video, you saw the leaves getting blown from the back of the combine. That's referred to as trash. It's just a collective term for all the tops and the leaves. And you can see on this picture of a field, they cover both the row and the furrows. And the primary consideration with the trash is that they can prevent new growth by covering up the plant that's the stalks that are underneath. So they try to avoid that by burning off the trash. That's commonly the way to deal with it. There have been research looking into trying to divert the trash into the furrows so that it's clear off the rows, and then the tractors go over them and then push them deeper into the soil. But that is something that's being worked on currently. And then you can think of other applications from a bioenergy perspective for how to handle with the trash. But currently, it's the most economically feasible way of dealing with the trash and not impacting the new growth, especially when you think about winter being cold and wet. It can really stunt the growth and prevent the crop from coming to maturity. That sort of wraps up the field side of things. Now we move on to processing. So this is where the sugarcane that was harvested from the field gets turned into raw sugar. And this is done in what's called raw sugar factories. Colloquially, it's also referred to as mills. Back in, I think, the 1800s, we had about 1,000 of these mills everywhere. They were a lot smaller. In the 70s, it was about 24. Now we have 11 factories in the entire state. They are a lot bigger than they used to be, and they process a lot more cane, and it's growing every single year. This is similar to other agriculture industries like dairy or beef, especially when you think about CAFOs, but they have been getting bigger and more consolidated. These can be either privately owned or cooperatively owned. Private ownership just means that the factory buys the sugarcane from the growers, and then they process it and turn it to raw sugar. Cooperatives are joint ownership between both the growers and the processors, and they share the profits. This particular sector employs over 7,000 people, both full-time and part-time. The season is very short. It goes between September through end of December or January. It's very intense. The typical shifts in the factories are 7 days a week, 12 hours per day. That is by far the most typical shift in a factory. And there's no time off for Thanksgiving or Christmas necessarily, or the New Year. Majority of the workforce during the season is migrant labor from South and Central America. But then there is a full-time crew that stays during the quote-unquote off-season, which is the rest of the time for about 6 to 7 months. Because the season is so intense, it's a lot of wear and tear on all the machinery and the equipment. So the off-season is the time when everything's stripped down, repairs are done, and people are focused on expanding for the next season. So that's kind of what each year looks like for the factory. So here's a few unit operations. This is not an exhaustive list, but I'll talk about these in very broad terms. So that when the cane gets delivered to the factory in these big 18-wheelers, this is showing an example of how one of these factories deals with it. They have a hook or a crane, and then the bed is tipped over to release the billets. This video I should credit to our communications photographer, Mr. Randy LeBeau. I call these one of his glamour shots because they're so slow, and they really show you the process in full effect, I think, of them. Some other factories have different setups for doing this. They have a much more massive crane, hydraulically powered, and then that lifts the whole truck over and tips it over into the cane yard. When the cane does get delivered, there's about a 12-hour, give or take a few hours, this way or that, time period before it gets processed. They're trying to reduce that time. I've talked about degradation before, that the shorter that period of waiting time between processing and after harvesting, the better it is, but that doesn't always happen. There have been concepts about first in, first out approaches for doing this, but if you think about a mill that's running 24 hours a day, a small snag happens and you lose a couple hours, that adds up in the front end of things, and the cane sits a little longer. So that's still, again, another active area of research that people are trying to look and reduce that. Cut to crush time, it's called. So this is how it's tipped into the cane yard, and then it's eventually processed. I'll speed this up a little bit just to show you the ending and the emptying of this trailer load. Okay, one of the first stages when the cane comes in, it's brought into the factory. The big unit operation in this case is called milling. Basically, you turn those billets into juice, you crush them and extract them. Before you do that, you try to fluff it up a little bit. These are pretty hard billets. So they go through another process called knives or shredders, and that fluffs up the cane as you see it in this picture. It's called shredded cane. And then it's passed through these 4 roller mills, basically 4 different rollers, top of each other. One of them is being driven, and then the billets or the shredded cane pass through it. And then the juice is extracted, as you can see in this picture, and then the fiber gets sent out. We'll talk about the leftover fiber. It's referred to as bagasse eventually, but the juice comes out. There's 6 different mills, typically 5 to 6, and they run in tandems, 2 along the factory floor. But the juice that gets extracted is then referred to as raw juice. So this operation is basically turning the cane into raw juice. That's our first material conversion, if you will. And then this juice contains all sorts of impurities, primarily coming from the field, such as soil. There's a lot of waxes on the stalk. There's trash residue, the leaves and whatnot. So it's important. Oh, there's also a lot of ash. So we try to clarify the juice or clear it of turbid and suspended particles. The way to do that, first they heat up the juice, then they increase the pH to prevent any sucrose degradation. The juice comes in around 5.2 pH, and then it's bumped up to anywhere between 6 to 7 to stabilize the sucrose a little bit more. And then you add some flocculants and let it settle for some time in a clarification tank. The flocks settle down, and then what you have then is the clear juice. This image is kind of showing what it looks like. It doesn't look super duper clear, but it's better than what it comes out of the out of the mills, having had all the particles removed. So now we've gone from another material transition from raw juice to clear juice. And then just as we're going through some of these unit operations, I want you to know that the goal of the raw sugar factory is to separate, purify, and preserve sucrose. So if you remember, we start around 12 to 14% of sucrose in the stock. That's prone to a lot of degradation, and we want to be able to separate it and concentrate it. Now that's where we're starting to talk some of that. There's a term used in the industry called the BRICS, which is a measure of the dissolved solids content, used as a proxy to estimate how much sucrose is present in a material such as juice. Now we begin the step of concentrating it by mainly removing water. So we have evaporators in this case to remove some of the water, and then you're starting to thicken the juice a bit more, leading to syrup. We have multi-effect evaporators. Basically, it's a train of them. You take the vapor from the first effect, use that to heat the material in the second effect, and so on and so on. This was an invention by a Louisianan, a free person of color at the time, Mr. Norbert Rillieux. He's credited for this invention of multi-effect evaporators because before then it was referred to as the process called the Jamaica train, where juice would be poured into a kettle, heated with firewood, and then you would transfer it, dissolved in an atmospheric pressure, into another kettle, again heated with its own fuel, and that was carried on until you had the syrup of the right consistency you needed. We don't do that now. You only need to heat the first effect or supply energy to the first effect, and then you can use the vapors from the preceding effects to heat the next one as you go. And then once you have your syrup, now you're thinking to start separating the sucrose from the rest of the stuff to purify it. What you feed into a crystallization tank, we'll talk about that in a second, but this next step is called a mother liquor because that's what you begin to work on. There's 2 stages of crystallization. The first is evaporative crystallization. It's done at reduced pressure. And then the second is the cooling crystallization, which you get further crystallization as your material cools. So the mother liquor, the syrup, and combined with any other materials, is fed into what are called vacuum pans under evaporative crystallization, which is the image in the middle. These vacuum pans are constantly heating the material as it's being filled from the bottom and the level rises. And then you increase the bricks or the concentration of your dissolved solids or your sucrose concentration with time as you go. And at a particular moment, which is called the supersaturation coefficient, when it's just right based on conditions of temperature, concentration, and vacuum pressure, you can then seed the material. Seeding is how we grow crystals from nothing, basically. You ball mill a bunch of refined white sugar, and then you add that to your material that's at the right supersaturation coefficient, and then you begin to grow crystals out of it. So that's how you grow these. And then as they get bigger, you transfer the material to the next pan, you grow them even further, and so on and so on. They go from C to B to A being the largest crystals. I don't know why it's in reverse, but that's how it is. But A crystals are the biggest in size, and C crystals are grown from seed, and they're the smallest in size. And then you let the material cool in these large cooling crystallizers. They're also called as vertical crystallizers. And then you finally finish growing your crystals. At this point, there's another material transition. You made what's called masic wheat. Masic wheat refers to basically a bunch of crystals in a sea of molasses. Now, what are molasses? I'm throwing a lot of terms at you. Molasses refers to the mother liquor from which you cannot grow any more crystals because the sucrose is way too soluble in it, and it's impossible under those conditions to extract more sucrose, crystallize it, and purify it. The goal of this operation is to make sucrose not soluble by growing it out of solution and crystallizing it. But there are considerations such as temperature or ash content of the material, which make it harder to keep crystallizing. So that's what we refer to as molasses. These are called blackstrap molasses. These are not what you would put on your pancakes. These are factory molasses. The stuff you get in the store, we'll talk about that in a second, but those come from the refinery. So these molasses are sent away. They're a byproduct. We'll come back to them in a second. But at this point, you have your masic wheat, and then you need to separate it from your molasses. And that's what happens in centrifugals or in the centrifugation stage. These are basically basket centrifuges. A small amount of masic wheat drops into them, into this chamber, and then they spin. The molasses get flung out from the screen, and then the raw sugar is held inside the basket, and then that's sent away for processing. The molasses go away. They do have an application for animal feed, but that's basically the separation stage. So we've gone from about 12% sucrose to over 99% at this final stage where we have raw sugar. That's the whole separation, concentration, and purification process that happens in the raw sugar factory under all those unit operations. Once we made this raw sugar, it's important to store it and store it in a way that it doesn't degrade. So one of the first things they do is they try to dry it a little bit more by flinging them in what's called a slinger. This is inside a sugarcane, a sugar factory warehouse where it's stored for a long period of time. And it's flung in the air to let it cool a bit more. It's constantly turned and moved around to help it dry further and not have anything degraded anymore. So this nearabouts concludes what happens when the sugarcane enters the factory and comes out as raw sugar. So we've mentioned a few co-products, but besides raw sugar, you also make what's called bagasse, pressed mud, and molasses. This image on the top is the bagasse. Again, this is the fiber that gets remained after you crush and extract your sugarcane billets and recover your juice. The remainder of the fiber is referred to as bagasse. It does contain a little bit of sucrose, and then you try to wash it down. It's called in a process called imbibition, but it has a small amount of residual sugars. And the primary use for that is to be burned in the factory, combusted to recover energy and make steam and power all your other processes. In Louisiana, factories use anywhere between 50 and 85, 90% of their bagasse. And the remainder is stored in piles right outside the factory. There's a joke that the only hills in the landscape are piles of bagasse in South Louisiana because it's pretty flat, besides these piles. They can add a lot of expense to the factory in terms of processing, especially because they can be a fire risk. So they need to go ahead and keep turning them from time to time. If the temperatures rise, they try to spray them with water. So they've been trying to come up with innovative ways of dealing with them. In many other countries, sugar factories burn off the bagasse, and they're able to co-generate energy and put it back on the grid. We don't necessarily have some of those incentives in Louisiana, so this is currently the situation with them. and there's a lot of interest in research for addressing this issue. There's also what's called press mud. If you refer from the clarification step, you remove a lot of the impurities, and then those impurities go into a filter, and then they're pressed out. A little bit more juice is extracted. It's sent back into the primary juice flow. And then those impurities that have been separated are then sent to a pond. They're referred to as press mud. Again, they contain a little bit of nitrogen protein sources from the plant, waxes, and soil compounds and whatnot. So that people have been looking into it as a soil amendment. This image here shows it being carted to a field and added to the field again. So that's one application for it. And finally, we also talked about molasses. This is, again, containing anywhere between 20 to 30% of sucrose. The goal of the factory is to have that amount be as low as possible, meaning that they extract the most amount of sucrose as crystals, but it's still a fairly significant amount of sucrose that gets left behind. Now, these molasses are not food grade. They're typically sold as animal feed additive for the most part in the mills from the sugarcane factory. And this video sort of encapsulates the factory as a whole. This is one of the factories that we went to. And again, thanks to Randy for this drone shot. This showing the whole operation. This is the main cane yard where the trucks come through. Crane picks them up and tips the pile over. And then you have all these other operators driving around, shoveling the cane and moving it to ensure that it's still first come, first serve for some base to some amount. This is the warehouse where the sugar is stored, the raw sugar, after it's been prepared, to the top left. And right behind here, you can start to see some of the bagasse mounds. There's a lot more than this, but this is all that's captured in this image. And to the top right now, you'll see what are spray ponds, where the hot processed water from the industry is sent and cooled off, and then it's recycled to a significant extent. So this drone shot kind of captures, and everything that we just talked about happens in these sets of buildings right here. So that concludes our processing section, and that now we go into refining. So all the raw sugar that's been produced in the factory is sold to refineries, and their whole job is to turn it into white sugar. So we'll take a short look at those. It's not my main area of research, so I'm not going to spend a ton of time on this. But basically, their role is to produce white sugar. The reason for white sugar is because that's what everybody buys. Think of it as sort of a blank slate. If you have it white, you can do anything you want with it. The brown sugar that you buy in grocery stores do not come from the raw sugar factory. They still come from the refinery where they're first converted to white sugar, and then a little bit of color is added back to produce brown sugar, golden sugar, turbinado sugar, whatever you want to call it, different grades of commercial colored sugars that are available. So in Louisiana, we have two different refineries, Domino and Louisiana Sugarcane Refining. Domino, you're probably familiar with the brand, a lot of packets of sugar with Domino labels on them. So 3 of the 11 factories sell their sugar to Domino. And then Louisiana Sugar Refining is a company that was set up as a cooperative, again, with Cargill and 8 of the remaining sugar factories in the state. Now they sell their sugar exclusively, their raw sugar exclusively to these refineries. And unlike the factories, they can operate year-round because they're not under the same constraint that the factories are with a degrading feedstock. Their feedstock is pretty well preserved. Their feedstock is a raw sugar. It comes in at a good consistency and quality, and then they try to purify it even further, going from about 99.1 to over 99.5 and more. So we'll take a short look about what the unit operations look like in refining. The first step when the raw sugar comes in, they try to mingle it or mix it with saturated syrup. All they're trying to do in the refinery is to remove that last bit of molasses that coat the crystal surface. So they mingle it with saturated syrup, and then they re-clarify it. Again, lime is added along with 2 different processes, carbonation or phosphatation. Basically, you're trying to flocculate it once again, and then clear it off. And then you take that white liquor, and then you filter it using a pressure filtration system to separate the liquor from the turbidity and suspended solids. And then you again re-evaporate and recrystallize it, produce your sugars all over again, and you centrifuge them, but this time the product is white sugar. And then the turbid suspended solids are produced here, the colored compounds, those are the molasses. Now they're sterilized and then sold as food grade products in grocery stores. So this is an extremely sterile operation. If you walk into a refinery, inside the plant, you're required to wear the white caps that people wear to have hair not go everywhere. So it's extremely well-controlled operation. But they buy the sugar from the factories in batches. They do their own quality control. They make sure that all the parameters are coming in exactly right so that they can pay the factories at a certain rate and then keep producing white sugar. So we kind of talked about the past and the current state of the industry, especially in Louisiana. Because I'm a scientist, I want to talk about research. What are some things we're trying to do in this area? So when we think about agricultural processing, we don't usually think of it as a manufacturing term, at least I didn't until I started working in this area. Conventional manufacturing, I would think of as plastics, semiconductors, or cars, where you have a bunch of input materials or feedstock coming in, and you're trying to produce a consistent product through this manufacturing step. That's what these boxes represent. The input variability, I don't think is quite as high, and then you're trying to produce a more consistent product. We don't necessarily have that luxury in agricultural processing. There's a lot of different factors. This is a biological material that is constantly degrading with time. Its properties change. If the season is unique, and say, for example, we get hit by a freeze like we did at the end of last year, you lose a lot of your crop. Your process has to adapt to constantly changing conditions. And I think that's what makes agricultural processing a lot more complicated and probably more fun to study because of that. And you're still expected to produce a pretty constant product, consistent quality product. So to go about doing that, if you keep thinking along the lines of manufacturing, there's this concept of industrial revolutions. Now, remember, I pluralized it. We all know about the one industrial revolution that we learned in school, basically starting in England with the advent of steam power. You had more mechanization, the first factories came online, and then good and bad effects of industrialization, but that was the start of industrialized manufacturing, right? And then theorists like to think that the second one came around the time of the assembly line, or that's what triggered it. Think about the Ford Model T, for example. Instead of building a product from the ground up, you now begin assembling it using more standardized parts on an assembly line. So that we think is the second industrial revolution. And then moving forward in the 1950s and 60s, as computers and telecommunications came on board, that signified another leap in our ability to manufacture. And that's thought of as the third industrial revolution. We begin to see some proto-automation, moving parts, basic robots, and whatnot. And finally, we think that we're in the fourth stage of manufacturing right now, which is a category typified by cyber physical systems. Basically, lots and lots of robots, lots of sensors and networks, and lots of communication, data management and logging, data analysis and decision making. So we're now going from where we have control systems that are unique to each unit operation, and then having a network of control systems that can talk to each other and try to communicate and interpret information and send it to an operator for decision-making purposes. So that's what we think we're headed towards, and using this as a guideline is useful for us in the sugarcane industry too. We think we're somewhere between 2 and 3 generations in sugarcane processing and probably all of agricultural processing. But the path forward is kind of established for us looking at other industries. So what we're basically looking at is going from the picture on the left to the picture on the right. That's Mr. Alejandro in the first picture, kindly agreed to let me take his photo. He's measuring visually the size of the crystals as they're growing in the crystallization stage. It's qualitative. There is no data logging or record keeping. but that's how it's been done. He has decades of experience and he's really good at what he does. Going from there to what you see on the right is mainly robotics and sensors doing more quantitative data collection and analysis and giving you information on it. If you recognize that, that's obviously the car factory Tesla, run by CEO Elon Musk, seen here reacting to a child dropping their ice cream. With this way forward that we think we've established, there are some other considerations that come to mind, like what are some of the ethics regarding this increased automation in the ag industry, particularly? The loss of livelihood is an obvious consideration, right? On top of that, can you make it safer, maybe? Can you train the workforce in these up and coming new technologies? So those are some of the other questions that I'm considering with my research, not just in automation and doing something with the byproducts, but also upgrading our workforce to be proficient in being able to work with some of these new technologies. That concludes my presentation. I'm happy to have shared a little bit about the industry that I work with and some of my own research in this area. I want to thank Mr. LeBeau for the wonderful videos and drone shots that he took, Dr. Collins Kimbang, professor I work with closely, who helped with some of the ag side of things that I didn't really understand. All the faculty and wonderful staff at our department, the Audubon Sugar Institute, and obviously the stakeholders in the Louisiana sugarcane industry. It's a joy to work with them and ask them for their problems. I think in some ways I have a very easy job. I just go and talk to people and they tell me what my research questions should be. So that makes it a lot of fun. I want to thank you all for your time. Open the floor to questions. If you need to contact me, my information is here. And with that, I'll pass off to Sarah.
Wonderful. Thank you so much, Anurag. That was fascinating. If anyone has any questions, please feel free to unmute yourself and ask those. And I'll get us started with one of the questions from the chat. Is brown sugar made by blending white sugar and molasses?
The answer is yes. The brown sugar you can buy in the store is. With molasses prepared at the refinery.
Okay. How is climate change affecting the growth of sugar? I'm sorry, growing of sugar in the United States?
That is a great question. Among all the challenges we have, this is probably one of the bigger ones. You're probably familiar, if you know about Louisiana, we have an eroding coastline. A lot of the parishes where sugar was planted historically are not, they don't necessarily have people, let alone sugarcane farming. So that's also part of the reason why the crop is moving further north and west. Traditional sugarcane growing areas are under threat. Hurricanes, which have become more unpredictable with time, especially exacerbated by climate change. Those have impacted the industry too. I think when we had Hurricane Ida in 2021, the industry suffered a big setback with losing about 2 weeks of processing time. When you think about a 3-month running period for your season, 2 weeks is a big chunk of it. So I think with just the unpredictability of it, it's something that's hard to prepare and something that researchers need to think more about moving forward.
Okay, we've got a couple more coming in. Are you aware of any research using the materials you mentioned, like syrup, molasses, sugar, et cetera, as a substrate for other biomaterials, pharmaceuticals, or similar?
I'm a little bit familiar with that area of research. It's not something that I directly work on, but I know someone trying to make cell-free proteins using these as a carbohydrate source. So I'm not a whole lot familiar with that area, but I could find more information for you. But that is definitely an active area of research that's ongoing.
Can the production of sugarcane in Louisiana and the United States at large be staggered to help solve the issue of the seasonal nature of primary processing of sugar?
Let me think about that for a second. I guess, would it be possible to add to that question? I guess what they mean by staggering. Are they saying branch it out more regionally or temporally?
Lope, that's your question. I'm not sure if you'd like to elaborate further.
My meaning is that can it be timed differently instead of having only this September to December harvesting? Can there be also growing of the sugarcane so that there will be also January to March harvesting, things like that?
Well, the cold weather really makes it hard to do that, going through the winter and coming out of it. And you've kind of missed the most productive time of the year for the plant to do the harvesting. So I think that would make it more challenging to accomplish that.
Okay.
But that's something I could ask more around with the experts that I work with, try to get more answers on that.
Okay, thank you.
A question about water. What is the water consumption for the plants growing themselves, and then also for the processing of sugar?
That's a great question. I know that sugarcane in other regions uses a lot of water for irrigation. We don't really have that problem in South Louisiana because we have a lot of water. So it's usually not irrigated. We have enough water from rainfall and the groundwater for the plants to grow. With processing, I think I mentioned a little bit about spray ponds and recirculating water. That's done in most of the factories. Some of them do use water from nearby bayous. I don't have a concrete number on the exact consumption, but where recirculation is practiced, I think the water consumption is pretty low. But yeah, I can try to find better numbers on an actual figure for how much that water consumption is.
Thank you.
How is the sugarcane field leveled? What is the slope? And what's the appropriate, and is it appropriate for harvesters?
The slope, was that right? Did I catch that right?
Yes,
How is it leveled?
I believe that is the question.
Okay, if I understand it correctly, the combine harvesters have a blade that cuts it at the right at the bottom of the stalk, and then the rest of the stalk, the stubble remains in the field, and then that comes back in the next year and the year after that. It's called retuning in sugarcane, but basically the yield decreases after year 3 or 4. So even though it's perennial, you want to replant it after about 4 years. But to my knowledge, the harvester takes care about, they set it at a certain height, they cut the stalk, and then it comes back up the next year.
Okay, headed in a different direction. A shell combat facility in Donaldson is in process to become an alternative fuel complex, and feedstock is going to become ethanol. How are sugar mills prepping to meet the demand, but besides just producing sugar for food?
Mm-hmm. Yeah, that is another excellent question, which again shows you the regional variability of the industry. If you were to go to the same industry in Brazil and maybe even India, they're focusing a lot on converting the sugarcane juice into ethanol. We don't do that because sugar is such a big commodity here. We use all the sugar we grow in the United States. We import sugar. So just the market for raw sugar is much greater in this country than is elsewhere. In Brazil, they have government legislation that directs X percentage to be fuel ethanol. So there, the industry is really a bioenergy refinery. They also burn all their bagasse and put electricity, but their primary product is ethanol, and then raw sugar is a byproduct in Brazil, just as an example, and for that one industry. But our incentives and our markets don't really dictate that at this point in time.
How is rainfall during harvesting? Do harvesters bog down due to the softer soil?
Yes, this is one area where Louisiana is very unique. We do not stop, even though it rains. Rainfall can be pretty bad. I just spent a year in Louisiana. I could not believe the amount of water that comes here. Even though I'm from another tropical area, just never seen rain like this. But we don't stop harvesting, even though it rains. Places like Florida do. I think we also put chains on our tires and try to keep harvesting. But there are better people that can answer that question beyond that. But yeah, we keep harvesting here because we just have a timeline. We're worried about the freeze. All the crop has to be processed before January or sometime in before mid-January at the latest.
Are seed billets and stalks stored over winter under refrigeration?
I don't think so. But let me look into that. I don't want to give out the wrong answer. I'm not positive, but I can look into it.
Are harvesters equipped with special equipment like tracks to help with wet conditions?
I have heard that they do add chains potentially to the harvesters. I have not heard about tracks. That doesn't mean someone's not doing that. To my knowledge, I don't think so.
Next question. Your chart showed biomass production decreasing over time while sugar yield increased. Is that due to selective genetics within sugarcane and trying to maximize yield?
Yes. Yeah, basically. And then also to the fact that the crop was migrating to newer areas where it hasn't been acclimated to yet. So I think the program took a while to catch up to it. But basically trying to maximize the sugar yield and consequently not as much on a focus on biomass productivity as well.
Other questions? I actually have a question. So here in Michigan, they grow sugar beets. And so when you purchase sugar in the grocery store, you'll need to read the labeling to see if it's from sugarcane or sugar beets. As a consumer, product doesn't really seem to make much of a difference, like in home baking and things. And you mentioned that sugar, all the sugar produced in the United States stays here because we use it all, in addition to importing. Is sugar beet something that can be grown in the South, or is that are conditions not appropriate for that?
I think that's what you said is correct. It's just not really made for the South, just because of the warm temperatures we have. I know the sugar beets industry, and I'm not a whole lot familiar with it, but they have the ability to let their crops sit out in the winter. They do not have to process everything right after harvest. So that is a big advantage to them. I'm not sure in terms of how well the crop will do here, but as an industry, from an industry perspective, the cold temperatures really help the sugar beet producers, processors up in the north.
Thanks. Next, what do you see the role of Internet of Things in sugarcane production, or what components of process need greater monitoring?
That's a great question. We are definitely, that's where the research is heading, especially in terms of automation, IoT and IIoT, the internet, industrial Internet of Things, greater incorporation of sensors, trying to automate more processes that don't necessarily require human supervision constantly, and trying to just improve consistency. So some of the areas that I think this would be relevant if you're looking at unit operations, I personally begun working in the crystallization section of things. To give an example, you saw the operator monitoring visually the size of crystals that's ever being grown. In this case, we were able to install a microscope that could constantly visually monitor and quantify the size of the crystals as they were being grown. The advantage of something like that is you can go back between batches and compare how your crystal growth curve was, or what type of size did you get to? Did you have a lot of fines? Were there any issues with doing this kind of doing the crystallization? That's one area. With regards to quality control at the downstream aspect of things, when you produce your raw sugar, if you're able to quantify right away what your quality parameters are, that helps you determine how to blend your raw sugar to sell to a refinery, for example. Real-time nature of things is very important. Oftentimes, so one thing I didn't mention in the talk is there's always a lab associated with the factory. that looks at the sugar coming in, the sugar cane coming in, incoming quality of the sugar cane, and then does periodic analyses to inform the operators on how they should modify the process, if at all. Just to give an example, every time you have a freeze and a thaw, the stalk breaks open, and then as it warms up, microbial activity increases, it degrades the sugar, they produce compounds that you don't really want, external polysaccharides, for example. And then those cause a whole host of other issues in processing when they go through the operations. So they control that using enzymes typically, but they need to know how much enzyme to add, what kind of enzyme to add. And then usually there's a time lag between those two pieces of information. The lab information is probably not available for a few hours. By that point, that batch has probably passed through the mill. So those are some things, if you could come up with better ways of testing and analyzing samples as they come through, that's one big area where I think the scope for IoT or Internet of Things for sensors and networks and data analytics can be.
Do you have a sugar mill on site? I'm guessing this person's asking about the LSU AgCenter. And are there, or is there a place that's open for tours?
Yes, we have a pilot scale planned on our facility. I would advise you to look us up at Audubon Sugar Institute. It talks us about the pilot scale mill. After we're done with this, I'll drop a link in the chat for where to find it. And yeah, we would love to give you tours to come down and explain the process to you. It's a lot smaller than the scale of things in the factory, but the nice thing is you can basically walk through it and understand what's happening at each point in time.
Wonderful. Okay, well, it looks like we've reached the end of our questions. If you'd all please join me in thanking Anurag again for this presentation. I'll just take a brief moment to let you all know. The next member hour in our series is scheduled for March 28th. We'll be joined by Chad Gregory, the President and CEO of United Egg Producers, for a discussion on egg production in the United States. Again, this session will be archived on our YouTube channel, so keep an eye out on our website for that. And if you'd like to register for future sessions, we'd love to see you there. Thanks so much again, Anurag, and thank you all for joining us.
Bye, everyone.
Thanks, Sarah.
Thank you. And Anurag, I'll post that link on our event page so we can share it that way too.
Thank you so much. Well, have a good rest of your day. Bye.
Thanks, you too. Bye-bye.